Okay, so paper 4 on our way there now with chi-squared. So chi-squared, you're going to see similar to Spearman's, Simpson's, and Lincoln's. You're going to be giving something you can read, and then of course a graph that's going to go with it. I recommend to read everything, read the graph, and look at all of the tables, as always when taking your ACE Marine exam. So on paper 4, we could see a different equation called chi-squared. So we're going to go ahead and run through a chi-squared problem. But of course, just when you're looking through this page, you're going to see that there are parts of a question that goes with our chi-squared. So let's go ahead and actually start at part B of number 5. This exam is actually October, November of 2022. This is the 4-1 version. So it says in 2012, scientists investigated the size of the bonefish around the island where the use of gill nets was banned. They estimated the ratio of the number of bonefish in 4 length categories that would be required for a sustainable population. The expected ratios for the different length categories are shown in table 5.1. So just like we're doing here, you can highlight anything that's typed by Cambridge, but I just want you to be aware of what we're looking at. We're looking at length categories, and of course we're looking at table 5.1 first. So you're going to notice we have our fish length category per centimeter. So we have under 15, between 15 and 35 centimeters, between 36 and 75 centimeters, and then greater than 75 centimeters. The ratio means how many out of the total were in that specific length category. So it says a sample of 1,500 bonefish, that's 1,500 bonefish, was caught. A chi-squared test was carried out to see if the population or the numbers of the fish caught in the sample fitted the expected ratios. So right here, this is what chi-squared is. To see if numbers caught fit the sample in order to make a population sustainable. Then we have our results in table 5.2. Notice we do have information missing. So something for you to pay attention to is where you have information missing. I'm actually going to put a highlighted box around it because that's something you should see right when you look at this question. When you're looking at the page, you know there is something more you need to do. So we're going to go ahead and learn how to fill in this table. It says length category less than 15. Notice your expected ratio actually came from table 5.2. So look at all of your expected ratios. It goes 5, 4, 2, 1. Same thing with our ratios from our previous table, which was 5.1. Then you get to expected number of fish. That's capital E. Capital E, you have to look. You're going to look very closely, and you should notice that we need a total. How do we figure out how many fish there were? Well, remember in the beginning, I highlighted your 1,500. So your total for both observed and expected should be 1,500. So if we add up 625 plus 500 plus 250, you're going to see you have 125 remaining out of that 1,500. Then, very straightforward, O minus E, that's observed minus expected. So in the next box over, it's 145 minus 125 gives you 20. Then you're going to take 20 and square it. That will give you 400. And finally, you're going to take the squared number and divide it again by the expected number. You'll get 3.2. Now, the next step is give the null hypothesis for this investigation. So a null hypothesis would mean there is no correlation. So null, think no. So if there is no correlation on the line for 1 point, we would simply say there is no significant difference. Or we could even say that the ratios of the fish in each length category in our sample compared to what was expected, there is no difference. So no difference, aka no correlation. So no difference between the ratios of the fish in each length category. Then it says to complete table 5.2. We've already done that step. That was for 1 point, but when you move forward, you're going to notice there is a second part of the question. Technically, it's actually the third part of the question. It says calculate the value of chi-squared. So similar to your Simpsons, your Spearmans, your Lincolns, you're always going to be given on the exam your chi-squared formula and the variables. But we need to understand that we need to plug information in. We already found this on our table, right? We had the O minus E squared minus E. So you're going to plug in 0.64 plus 0.45, that's the last column on the table, plus 0.9 plus 3.2. When you add up that last column, you're going to see 5.19 is your answer. You're going to write that on your line because remember, that sigma sign means to add. So you would add up everything in this last column. Now, of course, there is another step that we need to look at, which is degrees of freedom. Degrees of freedom will always be n minus 1. N stands for your sample size. So look at how many samples we have. 1, 2, 3, 4. So it's going to be 4 minus 1, which we already know equals 3. So we're going to look at 3 degrees of freedom. Let's actually highlight that instead. And we're going to go to our 0.50 value. The number in your p-value table, your critical value table, is 7.815. So our number is less than 7.815. So we are going to say there is no significant difference. The null hypothesis we created would be accepted. And that is because our value calculated is less than the critical value. So null hypothesis is accepted. There is no significant difference. And finally, the chi-squared, which is our calculated value, is less than the critical value from the table, which was 7.815. If our number was greater, then there would be a difference, and we would reject the null hypothesis. So that's just something to keep in mind based on what we know about the null hypothesis having no significant difference. And now we understand our critical value table. If your number is less, then there is no significant difference. The null hypothesis is accepted. Remember, that means there's no correlation. And then we already know that if our number was greater, that we would reject our null hypothesis. So if the number is greater than our critical value, remember this is 5%. So that's the one we're going to look at for our critical value. We want to look at the 5% for our degrees of freedom, which is specific for each question because each question may have a different sample size. And remember, N was our sample size. And we went above and counted that. All right, guys, if you enjoyed watching this video, I hope you found it helpful. Please like the channel, keep following along, and I hope you do wonderful on your paper 4 if you see chi-squared.